You've probably done this 1,000 times. You're on a video call, you walk out of your house, and your phone switches from Wi-Fi to 5G. But the call doesn't drop. Ever stop and wonder how that's even possible? It seems like it should break, right? Well, that seamless switch isn't magic. It's actually one of the coolest, most underappreciated bits of engineering on the entire internet. So let's pull back the curtain and see exactly how it works.
So yeah, this is the big mystery we're going to solve today. You literally change your entire network connection. Your device gets a brand new address, a new identity on the internet, and somehow the server on the other end of the world just keeps talking to you like nothing happened. How on earth does it do that?
Okay, so look at this. On the left is what our brains tell us should happen. Your phone is talking to a server, the Wi-Fi connection vanishes, and poof, the service left hanging. Connection lost. You'd have to start all over. But on the right, that's reality. The Wi-Fi dies, but your device, almost instantly, just pipes up and says, "Hey, server, it's still me. I'm just over here now, at this new address." And the conversation just picks right back up.
To get how this is possible, you need to meet the hero of our story, TCP, which stands for Transmission Control Protocol. The best way to think about TCP is like a super reliable, kind of obsessive courier service for the internet. It doesn't just drop off packages of data. It makes sure every single one is received, signed for, and that the whole conversation happens in the right order.
Every stable internet connection you make, from loading a web page to that video call, starts with something called the three-way handshake. It's basically a very quick, very polite digital introduction. Your device sends a little packet called a SYN, which is just, "Hey, can we talk?" The server answers back with a SYN-ACK, which means, "Yep, I'm here and I heard you." And then your device sends a final ACK, saying, "Got it." Boom. A stable connection is now open.
And here is the absolute key to everything. That handshake doesn't just open a line, it creates a formal TCP connection. This connection is identified by way more than just your IP address. It's a unique combo of the IPs, the specific port numbers, think of them like loading docks on a computer, and crucially, sequence numbers that label every single piece of the conversation. It's the conversation that gets the unique ID, not your device's temporary address.
And that brings us to the IP address itself. We think of it as our online identity, but it's much better to think of your IP address as just a temporary license plate. When you're on your home Wi-Fi, you have one plate. The second you switch over to the 5G network, your carrier just hands you a completely different one. Okay, now this slide right here is the big aha moment. Just look at this table. Before the switch, you have a Wi-Fi IP address. After, you have a totally new mobile IP. That changed completely. But look at the last row. The TCP Connection ID, it is exactly the same. That's the secret sauce. The server isn't tracking your license plate, it's tracking the unique ID of your conversation.
And this is really where the magic is. The server starts getting data packets from a totally new IP address, but it doesn't freak out. Why? Because those packets are stamped with the same TCP Connection ID and they have the next sequence number in the series. It knows it's you. It's kind of like if you're reading a book out loud to someone and you walk from the kitchen to the living room. You don't start the book over from page 1, right? No, you just continue with the next sentence. The story is unbroken.
And get this whole switcheroo happens insanely fast. Your phone's operating system is always monitoring your connection quality. It can see the Wi-Fi signal getting weak and flip the switch to cellular data in as little as 100 to 500 milliseconds. That is literally faster than you can blink. It's so quick, most of the time, you don't even perceive a glitch.
But let's be real, it's not perfect. We have all had that moment of pure frustration where the call does drop right in the middle of a sentence. So why does the magic fail sometimes? Let's take a look at the usual suspects.
Right, there are a few key culprits. Sometimes, a really strict firewall might see data coming from your new IP address and think it's some kind of attack, so it just blocks it. Older hardware might just not be smart enough to handle the change. And then there's a whole other protocol called UDP, often used for things like online gaming where speed is everything. UDP is like the anti-TCP. It doesn't do a handshake, it just blasts data out. So with UDP, when your IP changes, the server just thinks a completely new person started shouting at it. And of course, if the gap between networks is too long, say you walk into an elevator, the server will eventually just time out and hang up.
Now, as amazing as TCP is, it was designed decades ago. The internet is always evolving. So engineers looked at this whole handoff dance and thought, we can make this even better, especially for a world where everyone is on a mobile device. And the answer to that is a newer protocol. It's called QUIC.
This slide just lays it out perfectly.
With the old way, TCP, the connection is sort of identified by the two endpoints, including the IP addresses. It's a bit fragile. But with QUIC, the new way, the connection is identified purely by a unique connection ID, a big random number. It completely separates the conversation from the location. This means your IP address can change over and over, and it just doesn't matter. As long as you have that connection ID, the conversation continues. It's built for network hopping.
And if you're thinking this is some futuristic tech, guess again, you're using it right now. If you've used Google, watched YouTube, or scrolled through Facebook today, you've been using QUIC. All the major players on the web have adopted it because, well, it just provides a much smoother, more resilient experience for all of us on the move.
You know, this rock-solid connection stuff isn't just about making sure your video doesn't buffer. It is absolutely critical for some really high-stakes applications. Imagine emergency services in a disaster area needing constant communication, or self-driving cars that cannot afford to lose connection for even a split second, or a surgeon performing a remote operation using telemedicine. For them, unbreakable connectivity isn't a convenience, it's essential.
And I think that really gets to the heart of it all. The fundamental design of the internet is just incredibly resilient. I mean, it was originally conceived with the idea that parts of the network could literally be wiped out and data would just find another path. Your little hop from the coffee shop Wi-Fi to your cell network? For the internet's core protocols, that's just another Tuesday.
So, what do you think? If you learned something new about the invisible tech that keeps you online, do me a favor and hit that like button. And I want to hear from you. Drop a comment with your absolute worst My Connection Dropped at the Worst Possible Moment story. And of course, make sure you subscribe for more deep dives into the incredible, invisible infrastructure that powers our entire world. Thanks for tuning in.